Okay, we're looking at Logic Game 3, LSAT 40, June of 2003. Each nonstop flight offered by Zephyr Airlines departs from one and arrives at another of 5 cities, H, M, P, T, and V. Any 2 cities are said to be connected with each other if Zephyr offers nonstop flights between them. Each city is connected with at least one other city. The following conditions govern Zephyr's nonstop flights. All right, so what we really know is that in order to be connected, you just have to have a line between you, and that every flight has to be connected with at least one other flight. All right, so in other words, nonstop flight wouldn't connect 2 things at once. It's just one line between 2 variables. Okay. So Montreal is connected with exactly one other city. Honolulu cannot be connected with Toronto. Any city that is connected with Honolulu, if you connect with Honolulu, then you have to connect with Toronto. And if Philly is connected with Toronto, then Philly cannot be connected with Vancouver. And therefore, if Philly is connected with Vancouver, then Philly cannot be connected with Toronto. Okay, so this is kind of a diagram game. And it's extremely difficult because it's just intuitively awkward to try to solve it. And very few things can actually happen in this analytical game. So we would like to apply the hierarchy of rules and see if we can solve the scenarios. Now, what we should understand is that because M only connects with one city, okay, that means that if M connected with H, M would also have to connect with T. So M cannot connect with H, and also T cannot connect with H. All right, so that means that the only things that can connect with H, all right, are going to be, so because M can't connect with H and T can't connect with H, P and V are going to be the only things that can connect with H. All right, so the way that we're going to look at this is at the end of the day, what this rule really is it's an indirect first order rule, and it requires the creation of 3 worlds. There is only 3 things that can happen with H. H can connect solely with P, H can connect solely with V, or H can connect with both P and V, and that's what we'll do. We'll exercise this out. So we have H here and T here, okay? And then what we'll do, let me move this up just a tad bit. Okay, and then we'll just put our P and our V next to it. All right, now I'm not as worried about M right now because M can only connect with one city. So all M really needs, or with one flight, all M needs to do is just move around. Okay, M cannot connect with H because in order to connect with H, you'd also have to connect with T. So the way that we'll look at it is like this. P can connect with H only. All right, and so that would be all that H could do. All right, then I'll come over here. All right, so I could have P solely connected with H, or I could have both of them connected. Okay, that is both P and V connected with H, and that is all that H can connect with. Or I could have H connected with solely V. And that is all that can happen with H. H can do nothing more than that. And now it's a matter of working through to see what else we can do. Okay. So if we look at, let's start with this situation here. If P connects with T, P is not allowed to connect with V. All right, so the only thing that can happen with P is that P can connect with M here. All right. All right, now, P would be exhausted. P can't do anything more. P can connect with M if it wants to. T could connect with M, and V could connect with M. But where I have M being able to connect with any one of these, T would have to connect with V. Okay, because if I had M and P connected over here, and I didn't connect T with V, then what would happen is V wouldn't be connected with anybody. So I need to express this one more way. We could have a situation like this in this analytical game. Okay, where V and M were solely connected, and H, P, and T were, and that would be it. All right. So again, the reason why I have M in parentheses, it could connect with anybody if it wanted to, but T would actually have to connect with V. Now, why don't I connect V with H? Because I have it over here and here. Actually, if I connected H with V, then I would basically be creating this situation. All right, so this is all that can happen when only P is connected to H. Now let's take a look at what can happen in this situation. Well, if P is connected to T, P cannot be connected with V. So that eliminates that. The only thing that we need to be concerned with is what M can do in this. M could go here, M could go here, or M could go here. All right, that's the only thing that can happen if both P and V are connected with H. And these guys are all completed. They can't do anything else. Again, H cannot connect with T, and T is already connected with P and V, and the only thing T could do is connect with M, but M can connect with everybody. That's all that can happen there. Now let's look at this. Okay. All right, well, what can P do? P has got to connect with somebody. P could connect with V. All right, and let's move down a little bit. P could also connect with T. All right, and there's one other thing that P could do. P could just connect with M. All right, I have to represent this in the exact same way I did with V. Okay, if V isn't connected with anybody, V is going to have to be connected with M, and same with P. And in these other situations, this is all that can happen. I can put M in any of the three spots. And that's it. That is the entirety of this game. It is wholly solved. There is nothing more that can happen. And there are a total of nearly 6 scenarios. Okay? And so now it's time to just go through and answer the questions. Which one of the following could be a complete and accurate list of Zephyr Airlines connected to cities? All right, well, let's look at Rule 1. M can only be connected to one city. If you look at B, M is connected to Philly and M is connected to Toronto, so that eliminates B. B is out. Okay, if we look at the second rule, H cannot connect with T. E, that eliminates E. H and T are connected in E, so that's out as well. So we're just looking at A, C, and D. And if we look at rule number 3, it says if you connect with H, you have to connect with T. And in C, Philly connects with H, and Philly connects with T. Honolulu and Montreal connect, and Montreal never connects with Toronto, so C falls out. Okay, I mean Montreal can only connect with one city, and it could never connect with H. because if it connects with H, it's got to connect with T also, so we break the rule. And then 4, Philly is not connected with Vancouver. And if you look at D, we have Philly and Vancouver connected. So the answer to the question is A. All right, 12. If exactly 3 cities are each connected with Philly, then which one of the following could be a pair of connected cities? All right, well, let's just take a look at where we have 3 cities connected with Philly. It happens right here. You could have MP, M, T, and H connected with Philly. And the same thing could happen here. All right, here we only have 2 cities connected, 2 cities being V and M, T and M, maximum, T and M, 2 cities, and 1 city. So we're just considering scenarios 1 and 3 for this question. All right, so which one of the following could be a pair of connected cities? Could H and M ever be connected? No, they cannot. H and V, absolutely. That could happen right here in scenario 3. H and V could be connected. B is the answer to the question. Let's just keep going, though. Could M and T be connected? Well, M would have to be connected with P if we were going to get to 3 cities, so that could not be. D, M, and V, same situation. P would have to connect with M. And then E, P, and V. Well, P and V never connect in either one of these situations. So the answer to the question again is B. 13, which one of the following is a pair of cities that cannot be connected? H and M. Well, as we see, as we've deduced and as we see in our diagram, M can never be connected with H, so A is the answer to the question. Let's keep going, though, just to make sure. Can H and P be connected? Absolutely, it could happen there. M and P, we can show it anywhere on our diagrams. M and V, that can happen here. And P and T, it could also happen here. So again, the answer to the question is A. All right, 14, which one of the following could be true? M and P are connected with each other, but neither is connected with any other city. Absolutely, it could happen right there. M and P are connected with each other, and they're not connected with any other city. A is the answer to the question. Let's keep going, though. M and T are connected with each other, but neither is connected with any other city. Well, if we were to connect M and T here, T would have to be connected to somebody. M and T here, T would have to be connected. M and T here, T is connected. Same with this, and there is none here. So if M and T are connected, T would definitely have to be connected to something else. All right, P and T are connected with each other, but neither is connected with any other city. It's the same situation. If P and T are connected, somebody is going to be connected. The bottom line is if you connect, H has got to be connected with somebody, and that somebody is also going to have to connect with T. So no matter what we see, if we have P and T connected, they're going to be connected with somebody else. And we have P and T connected here, and P is connected with H. We don't have P and T connected here. P and T here, and T is connected with V. And P and T are not connected, so that can't be. D, P and V are connected with each other, but nobody else. P and V are connected. V is connected with 2 other people. P and V are not connected there. They're not connected there. This is the only situation where P and V are connected, and V is connected with at minimum 2 other people. And then the last one, T and V are connected, and neither are connected with anyone else. Well, T and V are connected here, and V is connected with P. T and V are connected, and V is connected with H. T and V are connected, V is connected with H. Same thing here. T and V are connected, but T is connected with P. T and V are not connected here. Okay, let's look at 15. All right, again, we know that the answer to the question is A. We went through B through E, and none of them could occur given what would happen on our diagram. All right, 15, if Toronto is the only city that is connected with Philly, then which one of the following could be true? So where do we have just Toronto and Philly connected? It could happen in 5, okay? That would mean M would have to be here or here. All right, Philly is connected with 2 other people here, connected with 1 other person here. I should say 1 other person right there. 1 other and 1 other. So we're only looking at scenario 5. Which one of the following could be true? Exactly 1 city is connected with Toronto. It would have to be at least 2. One city is connected with Vancouver. That would have to be at least 2. Exactly 2 cities are each connected with Honolulu. Well, if you look at Honolulu, it's only connected with 1. Exactly 2 cities are each connected with Toronto. Absolutely. Toronto could have exactly 2 cities connected to it. And that would put M over here. You'd have Philly with 1, only connected with T. T connected with 2, and then M would obviously end up over here. D is the answer to the question. But let's look at E. Exactly 4 cities are each connected with Toronto. Well, if you look at it, Toronto can only connect with 3 cities maximum. So E could not work, and D is the answer to the question. Let's look at 16. At most, how many pairs of cities could be connected? Okay, well, if we look at this, if you look at your lines drawn, then you can just add 1. Here it's 3 plus the M is 4. 3 plus the M is 4. Here we just have 2 lines plus the M was 3. 2 lines plus the M is 3. 3 lines plus the M is 4. But this one is the one, scenario 3, we have 4 lines plus the M, that's 5. And B is the answer to the question. All right, 17, if 4 of the cities are each connected with the remaining city, then the cities in which one of the following pairs must be connected with each other. Okay, so we have to determine where do we have a situation where all 4 cities are connected. It doesn't happen here, it doesn't happen here, it cannot happen here, here, or here. It happens here. Here, and just because this is the last question, all 4 cities could be connected with Vancouver, and that is scenario 4. So which one of the following pairs must be connected with each other? Must H and M? They cannot be. Okay. H and P, that cannot happen given this situation. H and V, that must be true. That's the answer to the question. Let's keep going though. M and P, no, V and M have to be connected. And then M and T, again, V and M have to be connected. So the answer to the question is C. Okay, that concludes Logic Game 3, LSAT 40, June of 2003. Thanks.